First, we will want to press the 683 ZZ bearings into the two wheels. There's 5 in each wheel in these small holes here. The side that printed up is the direction that you will press the bearings in from. Take a bearing, line it up with the hole, and then you'll need some kind of tool to press it in. In my case, this Allen wrench fits through the hole of the bearing and bottoms out on the shoulder, so I can use this to press it in. If your printer is well calibrated, they should go in snugly with hand force. You won't need any kind of press or hammer. Do this 5 holes on each wheel for a total of 10 bearings. Make sure that the bearings are pressed in all the way. There is a flange on the bottom side that the bearing should sit against. Repeat for the second wheel. Next, we'll want to prepare the 5 idler gears. They come in 2 pieces, one with the axle and one without, and they fit together with this star pattern. What we need to prepare is the printer will most likely leave little nubs on the top surfaces so they don't seat together quite flush. Using our emery stick, we're going to just sand down the surface on each half so that it fits flush. Doesn't take much pressure, we're just trying to remove the raised pieces of plastic. Now they fit together much better. Do that for all 5. And now we can install the idler gears onto the geared wheel. You'll take the idler gear with axle and put it through the back side of the wheel. This raised cone will be on the opposite side as the axle side of the idler gear. Take the other half, align it, and then drive a M3 by 8 millimeter fastener through there. The holes in all these plastic components are sized so that the fasteners will thread into the plastic. There are no threads printed in the plastic. They're just slightly undersized. We can now prepare the wheel brace. We have 3 of these pieces that will hinge together into a triangle. We'll use standard 1.75 millimeter filament as the hinge pin. You'll need about 2.5 feet of filament or 70 centimeters. There'll be a little bit left over. We'll just cut it off. Lining up everything. Just feed the filament through the holes until it comes out the other side. Pull back so that we're just about flush, and then back another several millimeters. Cut off flush on this end, and then if you want you can push that in by just a little bit to hide it. And there's one. As you're putting these together, make sure that the same side is facing down. This is my print bed. If I try to flip it over, it's just not going to line up correctly. Then we can bring the ends together. These will only close in one direction. If you try to go the wrong way, you're going to run into resistance there. Coming out the far end, backing off, cutting the excess, and then pushing that in slightly. We can now assemble the wheels to the wheel brace. There's a 3 pattern on the back here that the wheel brace fits into. And then we use our M3 fasteners into these 3 holes. For all fasteners, you want to go until it's snug, but don't crank on it too hard because they are just threading into plastic and you don't want to strip them. When assembling the second wheel, we need to make sure that it goes on in the correct orientation. There are 3 possible ways to assemble this. In the published version of these wheels, I've included an indicator mark. On this version, I've used silver Sharpie to distinguish it. There's a mark here following that ridge of the wheel brace. You just want to keep the mark in the same orientation. And then fasten together. Now we can install the carriage gears onto the carriages. These carriages are symmetric, so it does not matter which side you install this gear on. This gear, there's a cone shape here that'll mate to the bearing in the wheel assembly. And on the gear, it's got a pocket for that cone and then a repeat of the cone here. Just line those up and fasten with M3. And then we will install the carriages to the wheel assembly. The cone here and here are going to fit into the little pockets for the bearings here and here. Gears go to gears. You'll have to flex the wheel just slightly to get the carriage in between, and then it should drop into those pockets. So without any fasteners, this is pivoting around that, and then we'll just need to drive a screw. Make sure after driving the screw it still pivots relatively freely. On this side, we're not going to drive a screw yet because we will need to adjust the timing of these gears. After final assembly, we can just pop this out, rotate where it needs to be, pop it back in, and engage with the gear. So for now, just put them in. However, only putting screws on the ungeared side. The 2 cleats will need these skateboard bearings pressed into them. We've got the side that face the print bed, and the up side we press the bearing into. And then press until it's bottomed out on that flange. This one has a deeper pocket. It might be helpful to use the screw. There we go. For the motor cleat, we need to install a stationary gear on the back. Again, there are 3 possible orientations to fasten this. We want the correct orientation. There's a little indicator mark right here, and it needs to line up with the corresponding indicator mark here. Leave that a little loose for now so that we can find the next screw hole. Once we found 2, then the 3rd one will automatically be lined up. For lengths of wires, we're going to need to go from this side here where the barrel jack will go to the switch and leave yourself some slack. I'm going to cut that. And we're going to need to go from the switch to the motor. So again, that much, leave myself some extra slack. And then in order to have 2 directions here, we're going to need to cross wire these terminals together. So we're going to need a short piece of wire for that. Something like that. Now we need to strip these wires. I'm going to tin all of these wires before I start soldering anything. Just makes it a lot easier. And then likewise, I'm going to tin all the terminals I'm soldering to. All right. Our long wire was to go from the barrel jack to the switch. You really don't need to keep track of positive and negative here if we're just wiring straight to the motor. The motor cleat does have a lot of mounting points for additional electronics, specifically a Raspberry Pi Zero, an H-bridge, and a DC to DC power converter if somebody wanted to develop a smart system for presenting a specific carriage, then they could use all the mounting inside to do that. But if we're just going straight to the motor, we don't need to worry about polarity. Now, before we solder this end to anything, we want to go through our motor cover, our power cover plate. And before we do that, we need to remove this nut. This could have been done before we solder the wires on. Might have been a little bit easier. These are prone to get cross-threaded, so just be patient. Snug that up. Now, the motor, the power from the barrel jack is going to go to the center two terminals on the switch. Could use one more hand here. There we go. Then we need to connect the diagonals of the switch here for the motor reversing. So that's our short wire. And then on the other side, we need to make sure we cross. So we had green here. I want to have black here. And then where I have a black here, I want to use green. So we have green on one side, black on the other. Green to black. And then we need our motor wires connected to either side. They're connected by wires, so it doesn't matter which side. There we go. And we don't want to connect this to the motor yet, because first we need to get it into our cleat. So, starting through the switch hole, we can just squeeze that cover plate through. All of this will go in. I'm not going to snap this down yet because I don't know which direction drives the motor in which direction. So I'm just going to leave that loose. If you do snap it, it's easy enough to undo from the inside. My barrel jack is going to come through and then fasten on here. Having this separate power cover makes the wiring a lot easier because you don't have to do all the soldering inside of this motor cleat. But also, if you ever want to drive it with a different power supply, you just need to reprint this piece with whatever power adapter you want instead of printing the whole cleat over again. And I will include a start part of this cover without any openings in it, so that you can add whatever opening you need. Now I can take my wires, solder them to the motor. Now I'm done with the soldering iron. And my motor will assemble here in this orientation. I want to keep these electronics boxes clear. Turning over, we get 4 more M3s. Depending on the motor tolerances, these M3 by 8mm fasteners might be just a little bit too long. They'll bottom out in the tapped hole before they're actually snug. In this case, I think I'm okay. If you have a problem with that, you might have to use some 6mm long screws instead of 8mm like everything else. These you can crank a little harder on because they're going into metal threads. Alright, motor is nice and secure. Switch is still loose because we might want to turn this around depending on which direction the motor goes. And then we install the drive gear. The motor has a flat on the shaft. That flat just needs to line up with this screw hole. This gets pushed all the way down. Actually, before we do that, you want to start this screw. Don't go in all the way yet. Then put it on the motor shaft and tighten the screw. There we go. We've engaged the flat. Tighten that down. And at this stage, we can also put on our electronics cover. Right, and then for mounting this to the wall or the bench or whatever you're doing, have these adapter pieces. This I'm going to do as a French cleat on the wall. So I've got a French cleat adapter. This angled lip here is going to fit up under angled lip there and lock in and then screw in. And then if you wanted to hang it, say, above head with access to the switch from the bottom, you install the cleat there. I'm going to install it this way. And again, by having these as separate pieces from the motor cleat, you can make any adapter you need to fit on whatever wall system you have just by reprinting this small piece rather than the entire cleat. On the bottom side, I'm just going to use one of these standoffs. Then do the same thing for this one. Making sure that I get the cleat on the right side. You want the flat side of this facing the flat side of that. Now for final assembly, we're going to take our wheel assembly, and this stationary gear needs to fit in the middle of all of these idler gears. So and meanwhile, the drive gear needs to fit on the outside of the wheel. So you might have to just mess around a little bit. Kind of rotate things until it falls in place. So that's good. And I've got my M8 fastener. I need to change out to my 6mm Allen wrench. Goes through the bearing and then directly threading into the wheel. There's that one. And then the other side. There we go. Now I can apply power and then test the switch here. So I want it so that when I push this direction, the wheel moves that direction. So that's backwards. So I just need to rotate the switch and then install it in. So working my way around, I want to get these all clocked correctly. And just like that. You'll want to do this after it's installed on the wall, because if I do this now on the table, then when I go to put it on the wall, these are all going to be facing vertically instead of horizontally. Now switching back to the 2.5mm Allen wrench, I can put these screws in. Now switching back to the 2.5mm Allen wrench, I can put these screws in. And that completes the assembly.